So you've been asked to sketch this conic section and then find the center, the vertex, the foci, and the equation of the asymptotes. So before I start, I'm going to check to see what kind of conic this is. Because this is a plus and the sign in front of the y squared is a minus, they're different. It must be a hyperbola. If they were the same sign, then it would be an ellipse or a circle. So the first thing that I've done is I've reordered to put all of the x's together, all of the y's together, and I've added 101 to both sides so that any numbers are on the right. The next thing I'll do is factor anything from both sides, from the x's and the y's. When I factor a 4 out, I get x squared minus 4x. And when I factor out a 9, we have negative 6y equals 101. And part of completing the square will be to take half of the b term. In this case, we would have negative 2, square that, and get 4. A common error here, then, is to forget to either add 4 to the other side, or more commonly, to forget that really you're adding 4 times 4, or 16, to the other side. Similarly, half of 6 is negative 3, squared is a positive 9. Well, we're adding negative 9 times positive 9, or negative 81, to the other side. So now we will factor our perfect square, but if we kept track of what b over 2 was, as negative 2, that always goes in our factored form, and similarly here, b over 2 was negative 3, or you can just factor. Either way, you get the same result. And also, when we combine all of our like terms, we have 36. But we don't yet have a clean hyperbola because we need this to equal 1. So we'll divide everything by 36 in order to get it equal to 1 on all sides. So next we need to simplify this fraction, and we really don't want any numbers in the numerator. So we're looking at x minus 2 quantity squared over 36 divided by 4 would be a 9. We're really saying 1/9 is the same as 4/36. And here we don't want negative 9, we want negative 1 up top. So that means our denominator must have been 4 equals 1. So that really means a is the square root of 9, or 3, and b is the square root of 4, or 2. Now we can start to sketch out our hyperbola. We know that the center will be 2, 3, and so we'll start there. We'll go over 2, up 1, 2, 3. There is the center. Our A is going in the x direction. It's going to be right and left 3. So it'll be over 1, 2, 3, and left 1, 2, 3. And our B is with the y, so it's going up and down. So we're going to go 2 above and 2 below. And now we can sketch the rectangle that will control our asymptotes. And we'll go ahead and draw those in. From the center through the corners, and we know that the y is negative. So that means we will not have any behavior up and down. We're going to go in the x direction. We're going to open left and right. So that helps us get the location of the vertices, where over 2 plus 3 more would be 5, 3, and negative 1, 3. Now to find the foci, we need to recognize that they're going to be outside of the hyperbola. This is the value c, and therefore c squared must be equal to a squared plus b squared. So c is going to equal 9 plus 4, the square root, or the square root of 13. So that means over here we were at the center, 2 plus square root of 13 comma, we were up 3. And for the other vertice, we were 2 minus the square root of 13 comma 3. The last thing we need to find are the equations of our asymptotes. To find the equation of the line, I'll use point-slope form. The slope is either up 2 over 3 or down 2 over 3, depending on which asymptote we want. So we would have y minus y1 equals, we'll deal with the positive slope, 2/3. And we'll go through the center. It's a nice easy point to come up with. We would have over 2, so x minus 2, and y would be 3, so y minus 3. This is the equation of one of my asymptotes. The other will be the same center coordinate, so y minus 3 equals negative 2/3 x minus 2. These are the equations of both asymptotes.